Hi, in this video we will talk about a unique feature of Tezos named tickets. You may know that tickets is a data type that includes security mechanism to make it suitable issuing tokens or granting portable permissions. Tickets cannot be duplicated, so a single contract is always in a control of a ticket. In this way, ticket can represent control around something or a permission to do something. The tickets contains three kinds of information: the address of the contract that created it, the ticketer, some data with the type and value assigned to the contract, called wrapped value or payload, and an amount in the form of a natural number. Tickets have a type, and the type is based on the type of the value that you have on the payload. For example, a ticket that holds a string value is called a string ticket. There are four Michelson operations on tickets. To create a new ticket, you will use the instruction ticket. To read the content of a ticket, you will use the operation read ticket. To split the ticket into two different parts, you will use the instruction split ticket. And for joining two tickets into a single one, you will use the operation join ticket. So you will not use directly the Michelson instructions. So let's see what are the correspondent instruction or function you have on LIGO side. So to create a ticket in LIGO, you will use the Tezos library and the function create ticket. You will have to pass a payload and a quantity. To read a ticket, you will use also the Tezos library with the function read ticket. You pass your ticket as an argument, and it will return you the address of the ticketer, the payload, the quantity, and the ticket that is extracted from the function. To split a ticket into two parts, you will use Tezos.splitTicket. You pass the ticket as a parameter and the quantity you want to split between the first ticket and the second ticket. Here I have a quantity initially to 10 units and I want it to split with a first ticket A with 6 units and a second ticket B with 4 units. It returns an optional. You have to be careful in case you give wrong parameters here, for example. So tickets are a bit particular because they have to be created inside of a smart contract. It means that if you want to test tickets, you have two choices. Either you create a unit test and a smart contract that is not holding tickets at the beginning of the origination, and then you call an entry point that will mean the tickets inside of the storage of the smart contract. The solution is simple. It does not involve another smart contract. The problem is that if you really want to have tickets initially minted in your smart contract, or you don't want to use optional in the storage to say that you don't have tickets, it's not possible. So you have to use the second method. The second method is to use a utility function from the proxy ticket test utility library. And in this case also you have two different ways of creating tickets. I will show you only one of the two ways of creating tickets because the other one is a bit more complicated. I advise you to have a look on the LIGO documentation if you want to see the other way. So I will show you the way using init transfer and transfer. So here I declare, I will use a basic contract holding tickets, and I need to pass also a ticket as parameter. You can see the param of the main is a ticket of type string, so it's a string ticket. And in the storage, I have a map with a key that is a string and the value hold a ticket. Okay, when I call the main or the default entry point, I will add a new key with the ticket that I receive from the outside from another smart contract. So I deploy my contract here with an empty storage, and I want to call init transfer that will simulate someone that will define a function. So I first will use init transfer from the proxy ticket library that will define the way the ticket will be created and transferred to my function. So init transfer will take a function that takes a ticket as a parameter and return whatever you want, but here what I want is to have this ticket sent in the transaction. Here later I define the pair that will be necessary to forge this ticket. So I need to pass the payload, that is a string, and the quantity 10 here. Then when I will simulate a smart contract sending this ticket, it will reuse the function I gave before in the definition here of init transfer, and it will take the ticket settings I have declared just before and where I want to send it. So proxy ticket transfer will use my function here that will take the ticket and send back the ticket, this basic, of this ticket definition I have here to here the address of the contract I deploy. And then what I can do is to log and to see what is on the storage of my contract after this operation. So if I want to run this test, I can see that inside the storage of my smart contract, I have a key pair with my key that is default value, hard-coded value I have here. And I have here the definition of my ticket, that is the ticketer address, the payload, and the quantity. Thank you for watching this video, and see you next time.